Hello and welcome to our NASA Mars Lander final report. This project will go over ourselves, our background, the background for this project, the requirements, our final design, how we manufactured it, our results, and our conclusion from the project. Our company is Walters Egg Whites Incorporated, and I'm Jacob Blackburn, the project manager.
I'm Brandon Deeb, the construction manager.
And I'm Alex Lotz, the verification and test manager.
The request for proposal was from NASA, and they want us to build a landing craft that can keep 2 eggs safe from a drop on hard tile. The phase 1 summary for this customer requirements document: this Mars lander shall deliver astronauts to the surface of Mars. Its performance shall be demonstrated during videos recorded on launch day. It shall carry 2 pilots, which are eggs, and the lander should be reusable. The Mars lander demonstration vehicles shall survive the impact of a 12-foot drop. It'll protect 2 eggs from the damage, weighing up to 59 grams each. The loading and unloading should occur within 1 minute. The drops will survive the hard tile. They will land at once. The lander must be reusable, and the creation must be done in the time limit in class. And it shall deliver these eggs safely to the surface of Mars.
All right, so these are the drawings for the final design that we chose. If you look at the bottom, there's the front view. We can see that the parachute was 26 centimeters wide, and with the parachute, the whole lander was 56 centimeters tall, and it was equipped with the 10 centimeter long straws, and then the base, that was the cardboard box, was 12 centimeters high. So if you look at the top view, we removed the parachute so you can actually see it. The base of the lander was 18 centimeters wide and 10 centimeters in depth. And then if you look at the side view, you can see the horizontal straws that we placed just for impact, which we will explain later. So this is the item list that we bought. As you can see, we bought a piece of cardboard that ended up being the base. We bought the 10 sheets of copy paper for $1. We didn't end up using that in our final design. We bought the 4 grocery bags, which ended up being our parachute. And we bought the 10 cotton balls. And then the special salvage material, that was the straws. I believe that was probably the most important part. Next slide, please. And then, so this is the actual picture of the images of, this is the actual picture of the items that we bought. As you can see, we have the cereal box there, which is the base cardboard box. We have the colored straws, our cotton balls. We didn't use all those cotton balls. That was more than 50. And then 4 plastic bags, but we only ended up using 2. All right, so the actual manufacturing process is started with getting the box and filling them up with the actual cotton balls. And then inside of the box, we placed a piece of cardboard to separate the cotton balls, to kind of have like different compartments for the eggs. And so when we had the different compartments made, we made indentations in the cotton just to actually have room for the egg itself to like cradle it in a way that's like nice and snug, and there's no wiggle room where it can move around and break. And I constructed the parachute out of 2 plastic bags. I cut pieces of them off and then made sure to like really seal it with Scotch tape. And then the plastic straws acted as like a little crumple zone where they were facing vertical, horizontal, and diagonal, just like in any direction that may hit the tile floor, the straws will crumple up and absorb some of the shock. So to continue, there were no surprises really in the actual construction process. What we had in mind ended up being as somewhat easy to construct as we imagined. And we completed it well under the time limit. So with the cardboard box, it was originally too big for our liking, so we had to just make it a little bit smaller, just like cut cut it up and tape it together just so like the parachute can actually like hold the weight of it in a good way. The parachute, we didn't know if we wanted to use one plastic bag or two plastic bags. We ended up going with the two plastic bags because we saw that one plastic bag just would have been too small and wouldn't have supported the weight of the lander. And the straw direction, we didn't really know which directions to put the straws, and then we just came up with just putting them in any direction that it could hit the tile floor. And here are the actual images of our Mars lander. As you can see, we have the parachute there, all the straws going in different directions, and then the cereal box filled up with the cotton balls with the piece of cardboard in between.
Perfect. So as you can see here, we got a few of the dimensions of our landers. So the length was 26 centimeters, the width 17 centimeters, and the height was 56 centimeters. Pilot integrity verification. So we recorded 360. We began the timer at 55 seconds. We loaded the pilot, recorded the load time, which was also 55 seconds. We dropped the vehicle. Those are just another few more dimensions of the lander. And then the load time was 28 seconds. The unload time was 15 seconds. And then, yeah, and then official signatures on the right. And then here are just two videos of us dropping it. Actually, me dropping it from the first story, if you want to play them. So as you can see in those videos, ours dropped at a quickly alarming rate, but we also had the secure protection of the straws from the bottom, which also caused the eggs not to crack. And yeah. And these were our final results, Bonnie and Clyde, and they were both secured and protected after the first test run, and then the second test run on the right, also secure and protected.
So for the conclusions, comments, and takeaways, with our design, our team opted for a parachute design along with the cushion container. As this was the first time any of us had completed such a project, we believed incorporating both of these elements into our design would prove valuable in the protection of the egg. Furthermore, the straws were attached to the bottom of the container to act as a crumple zone, which stabilized the craft on impact with the ground. With our assembly, our construction consisted of one member crafting the parachute while the other two assembled the container out of cardboard, packed it with cotton balls, and attached straws to the bottom of the container. Finally, we all collaborated to attach the parachute to the container, which required all hands to hold the craft, hold the parachute, and tape them to each other. We completed the assembly well within the time limit and stress-free due to our modular teamwork. For the test results, with the two drops from 11 feet and 3 inches, our landing craft was successful in protecting the two pilots and allowed for a safe extraction. In both drops, our vehicle preserved the integrity of both eggs and remained entirely intact. The cotton held the eggs in place, while the craft was slowed by both the parachute and the straws. And for a rework/redesign effort, despite being successful, our design contains massive room for improvement. We only utilized $11.50 out of the $15 budget, which means many additional elements could have been added. Possible design elements that could have assisted our design are a larger, more stable parachute, more cushion with bubble wrap or styrofoam, or even more straws to help the craft survive impact. Our simplistic design allows for us to include more sophisticated methods to our craft if we were to remake it or redesign it in the future without changing the basic shape and concept of the lander. Thank you for watching our presentation.